we finished our invincible for the player, and right now we could leave this like for later on stages because this is like the polish phase, but you're gonna have a few more hours, I guess, of making this project, so why not make it look good so you actually don't get bored of it. In this video we are gonna add that effect where when you hit the stack or obstacle, as I called it throughout the course, it will not just disappear, but it will have a cool effect of actually falling apart. So let's get started. The first thing you gotta do is go to scripts, and here I'm gonna add a folder. Let's name this level scripts because these are kind of affecting our level. This one is rotating our level, and this one is spawning our level. And here I'm gonna add another folder, which will be our model scripts, or you can call them, what was the name? I did call name obstacle or stack script. Stack scripts, yeah. Now open it up, and here we're gonna add two scripts. One will be a C# script that will be called stack part controller. So this will be one part of the controller itself, and the other one will be the stack controller. I think it was like that. Yep, stack controller. So go ahead and add the C# script stack controller. Before I proceed to add them onto the models, I'm actually going to go and code them first. We're going to start things off with the stack part controller because the stack controller cannot work without part. First of all, we're going to of course add some variables. First of all, I mean too much first of all, we're going to add a private rigid body, which will be our rigid body. I'm just going to name it like this. This rigid body, we will need it to actually create the effect of our stack falling apart. We'll need some gravity to it. Then we're going to have a private mesh renderer, which we're going to call mesh renderer. It will actually not change any colors. I mean, you could do that, but it will check for its position. You're going to see later what is going on. We're going to have a private stack controller, which I'm going to call again stack controller. So everything the same, just the first letter will be lower, and then a private collider, which I'm going to name call, which will actually let's do it like we did for the rest of them, collider, which will actually just remove the colliders when we actually hit the stack with our player. In the awake function, we're gonna reference our rigid body and everything else. Rigid body equals to get component, and we're getting rigid body like this, open close parentheses, semicolon. Same for the mesh render. So mesh render equals to get component mesh. So mesh renderer. Fun fact, I can do like 100 not actions, but words per minute. But when you're talking and actually coding, it's a lot harder than you think. You can try it and see how you're doing it. And for the stack controller, it's going to be our parent. So transform.parent.get game component, and we are getting our stack controller. So transform.parent.get component and open close parentheses, semicolon. And last but not least, our collider, which will be equal to get component a collider like this, open close parentheses. After that, we are going to remove the update function, and we're going to add public void shatter. So this will create that effect which will make our stack actually float up and whatnot. So let me just align these, and we can start coding. The first thing we got to do is we're going to say that our rigid body equals dot is kinematic is equal to false. And I did not know why. I mean, I don't know why I put space over here, but it doesn't really matter. Let's continue. Then we're going to say that our collider dot enable equals to false. So these are two first things that we're going to do. After that, here comes the part of floating. First of all, we're going to have a vector 3, which will be the force point. So this is the force point where it's going to start. It's going to start at transform.parent, not position, but parent.position. Then we're going to have a float parent x position equals to transform.parent.position.x. Now, I'm not going to explain everything as I type out the code, but as soon as I type it out, you're going to know everything I know, which is everything you need to know. And then float x position equals to the mesh renderer dot bounds dot center dot x. Then we're getting the vector 3, so we can separate these. Vector 3 are sub direction, which will be equal to, and then open parentheses, parent x position, and then minus x position like this, which is less than 0. If that happens, then we're checking, then if it's true, vector 3 dot right. If it's not, vector 3 dot left. And then we can proceed to vector 3 direction. So direction, which will be equal to vector 3 dot up multiplied by 1.5f plus, why did I add a comma? Never mind, plus our subdirection dot normalized. So if it's going to the, okay, I'm going to split later on. And then we're going to have float force, which is equal to random dot range. Now these numbers over here are random. You can test them out, see what works for you, what doesn't. Then float torque, I think it's pronounced like that, random dot range from 110 to 180. And then here after that, we're going to add rigid body dot add force at position. And we're going to add force at direction, multiply by force, add force point, and the force mode will be impulse. So it will go fly away like it's nothing. Then we're going to add rigid body dot add torque, which will be our vector 3 dot left multiply by not x cubed but vector by left multiplied by torque that we have randomized. And last but not least, we're going to add rigid body dot velocity equals to vector 3 dot down, and then semicolon. So let me explain what's going on here. The first thing, when we come in contact with our stack, we're going to call the shader. The shader will remove rigid body, or actually have it to be kinematic, will be false, which means it will use gravity. And immediately it will actually be affected by gravity. After that, we're going to have a collider dot enabled to be false. So it cannot actually, if it happens that one gets hit by another one, it will not interfere or anything like that. Then we're having a vector 3 force point. Now let me go and show you where is the force point. So prefab models, let's say circle, and open up circle. So if you click on this one, you can see the pivot is right here. And when you're looking for the transform.parent.position, this is what you're getting. So this is the force point that we're going to have. Then we have the parent x position, which is again 0 where its x is, which is like here. We'll check this. And we have the x position, which is this part over here. So this is the mesh renderer, and it will get its own centered x based on the poly surface that we have over here. So why we need this? Well, let's go to this code over here. So this is a subdirection. Subdirection will be equal to parent x position minus x position. Now parent x position, let's say it's 0 minus x position. If it goes to the negative side, it's going to be vector 3 dot right. If it goes to the positive side, it's going to be vector 3 dot left. Now what's over here? What's this? I forgot the name of this. If I remember, I'm going to put it somewhere around here, like so you know how is this called. But basically this is like an if statement. So we're checking if our subdirection is like less than parent x position, or actually no, we're just checking like parent x position dot minus x position. If it's less than 0, then we're saying that our subdirection equals to vector 3 dot right. Else we're going to say that our subdirection equals to left. So this here is the exact same code as this here, but we're doing it in one line. So we're checking if our subdirection equals to this over here, and then we're adding an exclamation mark. So this will check if this is true, this will happen. If this is not true, this over here will happen. As I said, I forgot the name of this, but it's really useful and I use it sometimes when it comes to these situations. Then we have vector3 direction. So this will be the actual direction, which will be vector3 up, multiply by 1.5. We're multiplying it so it goes faster. And then plus subdirection, which is it will go right or left. So that this is what's happening. And then we're seeing that normalized. Why normalized? If you never ever created any game or wasn't much into the 3D stuff, when it comes to the normalized, if you're going forward and having only one force applying, it's going to be, let's say, 5. If you go to the right, then it's 5. But if you go diagonally, it will be 5 and this 5, and I do not know the exact reason, but it will not be only 5. When you're going to the direction, it will be like 6.5 force because it's applying 2 force at a single time. That is why we're using normalize, and it will return magnitude of 1. So you cannot go past that 1, which is by default forward or right. Then we're having the force, which will be randomized. And then again, we're applying the force that we calculated by the force point, which is at this from the center. And then force point impulse. So this will be like an explosion. It will just go away. Torque Q, it will just rotate itself. So around it. Where is it? I think, yep, it's on the axis. It will just rotate like this around itself. Just, it will not have anything. So it will rotate like this, but one single part, not the whole thing. And that will be it. So this is how we are approaching that problem that we're trying like to fix, to add, whatnot. Then we're having a public void remove all childs. So this is what's happening. So if you remove this one from the child, it will actually rotate normally. And here we're going to say for int I, if I is less than transform.child count. If that is true, then we're saying transform.getChild, and we're getting the child at index I dot set parent. So set parent to be null, so no parent at all, and then here I minus minus, and then add a semicolon. So it's always going to be 0. So here we're like increasing it, here we're decreasing it. So it's always going to be 0, and it's going to go as many times as we have our children. So it's going to go 4 times. And if you did not know, when it comes to the child count, it's same as an array. It will go 0, 1, 2, 3. And every time you remove this one, so if I cannot remove it, let's remove it out safe. So if I remove it, this will be now 0. If I remove it, this will be 0, and so on and so forth. So let me look like this, and then we are good to go. Other than that, we're pretty much done with this script over here. We're not going to call anything here, but we're going to go back to assets, then back to script, and then we're going to go back to our stack and stack controller. Over here, we're going to add new variables. Of course, that's always what we do. The first variable will be serialized field, so we can see it inside of the Unity Inspector tab, and then private stack part controller add an array, which will be stack part controls, like this, equals to null. What's this over here? By default, when something is private, so let's add a private Boolean test. When something is private, you cannot see it inside of the inspector tab. Let me just add it here. You cannot see it, but when you add the serialized field, you can see it. I talked about this before, but if you're not familiar, I'm going to show it really quickly one more time. You can see when it's not there, you cannot see it. Same goes if it's public, you can see it, but if you use like hide in inspector, by default, you will not see it, so you can see it, and then bam, it's gone because we added hide in inspector. So these are like some basic stuff you should probably know, but if you did not know, this is what's happening. Then we're gonna have a private stack controller. Then we're gonna add, I'm not sure if we needed this right now, so I'm gonna leave it for the later purpose. I'm not sure, but if we need it, I'm gonna go back to it. Again, void start and update not necessary. And here we're gonna have a public, so let me add tab, public void shatter all parts. So this will actually be called when we want to remove all of these. We're gonna check if transform dot parent is not equal to null. So if you're actually a parent of something, which is basically a rotator, if it is, then we're going to say transform.parent actually transform.parent equals to null. You can set parent null, doesn't matter. So you can use this or transform.setParent. That's what I want to say. After that, we're going to say find. Actually, that will be for the later on, not right now. Then we're going to have for each. So for each, not for, but for each, tab, for each variable, which will be stack part controller. The name of the item, we're going to call it, how are we going to call it? Let's call it O, like an object, in the collection of stack part controls that we have up here. So for each stack part controller, which we're going to call O, in the stack part controls, we're going to do what? We're going to say O.shader, like this. So for every single part that we have, so for every single of these, we're going to call out our O.shader. So this will actually initialize and activate the thing that will actually go and make them float. After that, we're going to remove all parts, which will be a start coroutine. So let me go ahead and add it. Enumerator, like this, remove parts, like this, and then curly brackets. Here we're going to say yield return new wait for seconds. So we're not going to remove them immediately. So 1 second should be enough for the stack part to actually go away from the screen, so you don't actually see it like disappear. If you need more seconds, just add it, doesn't really matter. Then for each, again, for the each, not for, but for, I'm just going to copy this. For each stack part O in the stack part controllers, we're not going to shader, but we're going to remove all childs, and then we're going to destroy itself, so destroy game object, like this. That's all we have to do. And yeah, basically that will be it. And I think this here might not be necessary, even though I added. We're going to see later on. And the last thing we need to add is inside of here, we're not going to destroy it, but we're going to say target, so target dot transform dot parent dot game object, or actually dot get component, and we're getting stack controller, open close parentheses dot shader all parts, and do that for this one here and this one here. Also, what you have to do, this will be a bummer, so I'm gonna actually skip it, but I'm gonna show you what you need to do. You will, okay, I have the rigid bodies. You're gonna have them all and just add here stack part controller, and then add here. So just close it up, use the dock, add them, and bam. And this needs to be added for every single, I'm gonna go out to save for every single part. So let me go to the level, go to circle 1, add here stack part, not part controller, but stack controller, add stack part controller, and then so on and so forth. I'm gonna skip this through or speed it up depending on how do I feel like it, and I will see you guys when I'm done. And voila, we are done. All there is to it is we can test it. So let's start. And if I go and bam, you can see it's working. Now, of course, if you're not satisfied with something and they're not being destroyed, that's one problem. So here we go, they're just flying around. That's weird. If you're not liking like the some effects, like maybe it's too much force, too much something, you can always go and actually remove that. So the problem is I forgot to add start coroutine remove parts, open close parentheses, semicolon, and voila. I mean, you can leave it, but it's bad practice, because imagine if you're having too much of work, it will not be actually able to be added onto like smaller phones, and that is not what you're trying to achieve. And it's bad practice, because you're actually having and trying to keep objects that you're not using. It's just ridiculous. You never do that. And one more thing I want to try is actually add this Let's see if anything will change. I think not, but yeah, nothing will be changed. Everything will be the same. So yeah, that part over here is not necessary. I of course did not think that through when I was building the game. So yeah, I did it right now. So I'm forgiven. Am I right? I'm forgiven. So yeah guys, that will be it for this video, and I will see you in the next one.